Hello again. In previous videos, you've learned how to use variables to store and label your data, and how to work with different data types, such as integers, floats, bools, and strings. In this video, we'll explore data structures, which are collections of data values or objects that contain different data types. Data professionals use data structures to store, access, organize, and categorize their data with speed and efficiency. Knowing which data structures fit your specific task is a key part of data work and will help streamline your analysis. A data structure is a collection of data values or objects that can contain different data types. So, data structures can contain data type elements, such as a float or a string. Data structures also enable more efficient storage, access, and modifications. They allow you to organize and categorize your data, relate collections of data to each other, and perform operations accordingly. One data structure in Python is a list. A list is a data structure that helps store and, if necessary, manipulate an ordered collection of items, such as a list of email addresses associated with a user account. Lists store sequences of elements of any data type. A sequence is a positionally ordered collection of items. However, strings are sequences of characters, while lists store sequences of elements of any data type. Note that different data structures are either mutable or immutable. Mutability refers to the ability to change the internal state of a data structure. Immutability is the reverse, where a data structure or element's values can never be altered or updated. Lists and their contents are mutable, so their elements can be modified, added, or removed. But strings are immutable. Think of a list like a long box with a space inside, divided into different slots. Each slot contains a value, and each value can store data. This could be another data structure, such as string, integer, float, or another list, or output from another function. When working with lists, you use an index to access each of the elements. Recall that an index provides the numbered position of each element in an ordered sequence. In this case, our sequence is a list. So let's go ahead and explore these different data structures in a Jupyter notebook. So lists are one of the more common data structures, and they're pretty straightforward. A list is pretty much what you think it would be, an ordered collection of items. To create the basic data structure, we place values between the squared brackets like this. So I have I_list equals 2, 4, and 8, so all separated by commas. So we can go ahead and see what this printed out as. So we can go new cell here and then my_list, and you can see here we have it 2, 4, and 8. Right now we can also make another list here, my_other_list. So you can see we have a mix of different types. So we could do not just the same type, but a bunch of different ones. We can add duplicates, use a mix of different types, even have like a list of lists. So this makes it really flexible and quick and easy to use. So I'll go ahead and run this cell. And so I have my_other_list here, and I'll go ahead and print out so you can see what that other list looks like. And you can see there we go. We have 2, 4, 8, 7, 3.6, and 9. We can access the list items, which are also called elements, through something called indexing and slicing. So let's look a little bit at what this is. So indexing is about getting a single item or a single element, and slicing is about getting multiple elements. So let's start with my_list here. I have first, second, and third. So you can see my_list defined right there. The first thing you should know that in Python lists are 0 indexed. That means if there are 3 items in list, they're positioned as 0, 1, and 2. In this case right here, we have first, second, and third. This would actually be index 0, this would be index 1, and this would be index 2. So let's see how you would pick this out. So let's add a new cell here, and we'll do my_list, and then we're going to use indexing first. So the way we index, we take our list variable, we use square brackets like that, and then we put the index number. So in this case, I'll put 0, and that will give us the first element in the list, because remember, 0 indexed. So you can see here we get the first element. If I put 1 here, that would give us the second element. Again, starting from 0. So 0 and then 1. So this should give us second. And lastly, if we put 2, we can see we get the last element. So let's try another one. So let's say we have colors. This list here called colors. We have red, blue, green, and you can see here we have the index 0, and that will give us red. Colors 1 will give us blue, and lastly, you'd expect index 2 would give us green. Now, you might be wondering, what if we use the index that's beyond the end of it? Well, if we do this, we actually get an error, and it's specifically an index error. If you go past the length of the list on the index, you'll get this error. If we wanted to see all of the colors at once, you can see here we have that red, blue, green. Now, Python has a really cool trick where we can use negative numbers as our index. So this is interpreted as in counting from the end of the list, where the last element can be reached with a -1. The second to last element can be reached with a -2, and so on. So if we wanted the very first element, we can count backwards. So we go like -1, -2, and then -3. So if I do colors, -3, we'll actually get red. And if we do colors, -2, well, what is that? Well, we start from the end of the list here, and we start with -1, -2, and that would give us blue. And so getting the very last element, which is very common using this pattern right here, -1, well, that's just looking at the end of the list here, which is just green, and that's our -1. So this should give us green. But let's say we want multiple values from this list. That's when we can use something called slicing. We define where we start inclusively and where we want to end non-inclusive with a colon in between. So what this looks like, we have our start part. So that's going to be inclusive, and then a colon, and then our end index, which is going to be non-inclusive. It's not going to include that number. So we'll see an example what this looks like. So let's go back to our colors, example colors, and we're going to slice it. We're going to start with 0 and then end at the index 1. So the start is red, the end would be 1. But remember, this end piece is not inclusive, so it won't include that last element, that last index 1. So we should just get red. Now, note that we didn't just get the string red, we actually got a subset. So this is actually a new list now. So note that's a little bit different from even though we just got red, like we would do with indexing, we actually got a list of red. Now this is a little more obvious when we have something like 0 and then insta 2. So again, we're starting at the 0 index, which is red, and then we're going to end at the second index. So in this case, 2 will be associated with green. So you can see we get 0 and 1, and then we don't get 2. So we're going to get red and blue as a list, and you can see, sure enough, that's what we get. Next thing we want to do is well, let's say we go from 0 to 3, if you note this. However, if you go from 0, 1, 2, and theoretically 3 and whatnot would be over here. So it turns out this will actually get you the whole list. So if you actually put 0 to 3 here, this will actually give you red, blue, and green. Pretty handy. So you might be asking if you want to include just the last element. And there you're not having to worry about the exact number. You're just like, all right, I want to start at this point, and then we're just going to get to the very end. Python has this nice little shortcut where we can just go ahead and leave it blank so we can see we start at 0 and then go to the end. And this is equivalent to doing 0.3, and you can see we get red, blue, and green. That'd be really useful, especially when you know you just wanted the end, but you don't remember exactly how many elements there are. So we can actually do something very similar with the beginning, where instead we leave out that 0, and we have just emptiness, a colon, and then where we want it to end. So this will basically tell Python's like a shortcut, like, okay, I know I'll start at the beginning, in this case from red, and then go until I hit this index 2. So this is equivalent to writing 0:2. What that would look like would be including red, including blue, which is index 1, and then not including green, remember, because that's number 2. So what that looks like is just red, blue. So we can also do some kind of cool. We can actually grab the specific element. In this case, let's grab index 1, which again, remember, is going to be equivalent to blue in this and assign it to pink. So this will actually change the list. So you can see here, instead of getting red, blue, green, we now have red, pink, green. We can do a lot with lists, and there are a lot of different built-in methods to work with lists. We'll focus only on a couple that are extremely useful and commonly used, though. The first built-in method that we have is len, and len basically stands for length. So that's going to tell us how long this list. Here I have my _other_ list, which is pretty long too, for 8, the string 7, 3.6, and 9. if I run this right here, well, how many elements is that? Well, I could count it individually, but Python will tell me that's 6. So you can see here I have 1, 2, 3, 4, 5, and 6. So good. Python knows how long the list is. We can go back to colors, which is a much shorter list. We can see as 3, so this should return 3. One thing we should be aware of though, if there's an empty list denoted with like these 2 square brackets. So this is something called an empty list. If you call in on this, what do you think? How long it's going to be? Well, it's going to be 0. So that kind of makes sense. An empty list has nothing in it, so its length is 0. You can also add stuff to the end of the list with .append. So here we have colors, which remember was red, pink, and green. Now, so just to kind of confirm that is what it is, you see colors. Yeah, red, pink, and green. So now we can actually append blue in it. And this will actually just add on, basically tack onto that list, blue. And note, this will actually change the list. So note that we're not making a copy of this. We're actually saying, take that list and add on a blue at the end. So you can see here we get red, pink, green, and blue. Note that if I called this again, it would actually add blue again, right? And I can keep running this over and over and over. And you can see you can do this over and over again. Another common method for modifying lists is insert, which requires 2 arguments: the index number of the element to be modified and the contents being put in that slot, such as a string or integer. Let's investigate how insert function works. Returning to our list of colors. Now, let's add an element at the beginning of the list. In the first parameter, we'll put 0. Then, type purple as the second element. Now, purple is inserted at the first spot at index 0 in our colors list. To remove an element from a list, let's consider the remove method. Remove is a method that removes an element from a list. Similar to the append method, remove only requires 1 parameter. Now our colors list no longer has red. If we try to remove an element that is not in the list, like yellow, for example, we get a value error. Another common way to remove elements is with the pop method, which uses an index. Pop extracts an element from a list by removing it at a given index. So, to remove green, pop the third element in the list with index number 2. Our colors have changed a lot since we started, but it's always the same list, the same box. We just modified what's inside. At this point, I want to address something that new learners of Python often wonder about. You'll recall that strings are immutable and lists are mutable. What this means exactly might not be clear at first. A new example will help make this more clear. Whenever we modify a string, we always have to reassign the change back to the variable that contains string. This is overwriting the existing variable with a brand new one. Notice that we can't overwrite the character at index 0. We get an error. However, we can do this with a list. That's why lists are considered mutable. As a data professional, sometimes it will be more important to access and reference data than to change and manipulate it. When you simply need to find some information, but keep the data intact, you can use a data structure called a tuple. A tuple is an immutable sequence that can contain elements of any data type. Tuples are kind of like lists, but they're more secure because they cannot be changed as easily. They're helpful because they keep data that needs to be processed together in the same structure. Tuples are instantiated or expressed with parenthesis or the tuple function. Here we have a tuple that represents someone's full name. Notice that it was instantiated using parentheses. The first element of the tuple is their first name, the second is the first letter of their middle name, and the third is their last name. The position of the element is fixed in tuples, so you can't add new elements in the middle, and you can't change any of the elements. If we try to change the first letter of the middle name, which lives in index number 1, from J to K, the code will throw an error. You can add a value to the end, but only if you reassign the tuple. Another way we can create tuples is by using the tuple function to transform input into tuples. In this case, our name is represented as a list. We can convert the list to a tuple by using the tuple function. Notice that the name is no longer a list, so it doesn't have the brackets anymore. So tuples are similar to lists because they're ordered and they have a length, and that we can use len function. We can use len here, you can still see the length here. We can still grab it by index, so that'll grab us the first element, because remember, 0 index, we can get the first name here. We can also use the negative, so -1, to get the last element, which is here the last name. So we could do all of those different things that are very similar to list. However, tuples are a little bit different, and the biggest difference is that it's immutable. For example, .append, if I try adding appending k here, I'll actually get an error that says, hey, tuple has no attribute append, and we basically can't add on to a tuple. A useful pattern, though, that comes with list and tuples, but are specifically used a lot in tuples, is something called unpacking. Let's say I want to get the first name, the middle name, and the last name from the full name tuple we've created. I could, let's say to grab the first name. Well, I can do square bracket 0 and then a square bracket 1, right? And I could assign these each a new variable, so I could do that. But there's this really cool method called unpacking, and what we can do is we can set each variable to an individual element like this. In this case, I have first name, middle name, and last name equals full name. The stuff on the left here, separated by commas, should matches to the stuff that will be on the right here. So again, this can be done with tuples and lists, but it's more frequently done with tuples because they have a set size. Using tuples in data professional work helps make your processes more efficient. It saves memory and can really optimize your programs too. Plus, when others collaborate with you on your code, your use of tuples will make it clear to them that your sequences of values are not intended to be modified. This is yet another great way to save your team time and effort. Great work, that's all for now. After all that talk about lists and tuples, I think we deserve a snack break. Don't forget to smash that like button, subscribe, and ring the bell to stay updated. In the next video, we will continue exploring Python data structures, dictionaries, and sets. Thanks for watching. I'll catch up with you again very soon.